Everybody. Thank you, Austin. So my talk is a year after ChefConf, lessons, shortcuts, and bloopers. Preamble, or daily gratitude practice. Thank you. I want to thank all of you for coming to my talk. That's really cool of you. And I want to thank all of you for coming to ChefConf. That's even cooler. Most importantly, thank you for being part of the community that's using technology to change the world. Please don't build Terminators. So about this session, or this talk is boring, let's leave. This is part of the Welcome to Chef track, and as such, it's geared towards newer users. So there's no cool LWRPs, HWRPs, or MUDs built for this session. The architecture stuff is definitely battle-hardened, though, because I super enjoy sleep. We're going to talk about AWS, Terraform, Chef, auto-scaling, and all the other things that make infrastructure great. We're going to talk about chef-driven monitoring with Nagios, iCinga, and NRPE. We're going to talk about Git hooks and code quality tools. We're going to talk about Cookbook versioning. And we're going to talk about complexity, refactoring, building to replace, and refactoring again. And there's going to be a bunch of cultural stuff weaved throughout. Now, initially, when I was trying to create this talk, I wanted to keep it highly functional, very practical, very code-driven. But every time I tried to bring something up, culture kind of popped its head in the doorway and said, you know, you can't do that without me, right? So there's going to be a bunch of culture stuff in here as well. So if you're still here, this talk is for you. The chef community has made my job better. It's made my life better. I'm here to give back to the community. This is my attempt at doing so. Whether or not I succeed, that's an open question. This is my attempt. Ask questions as they come up, okay? It's not an interruption. Raise your hand, make a noise. I want this to be interactive. I've heard this talk so many times by now. It'll be better if it's a conversation. And I don't want you to have to wait 40 minutes to ask a question about the third slide. If you're watching online, tweet me at vim.bashrc, and I will get back to you as quickly as I can. I'm terrible at Twitter, though, so full disclaimer. A little bit about me, or who are you and why should I care? Hi, my name is Matt. I've been building scalable internet things at various places in the New York area over the past 10 plus years. I've worked in enterprise, worked in startups, and I've worked in offshoot labs, whether it was an acquired startup or an enterprise initiative that was spun off and run like a startup with independent management and independent infrastructure. I've seen a lot of things in that time. Like this is a real photo. Took this photo at a data center. I've seen the rise and dominance of cloud computing, and I've been part of that conversation as well. I've seen the emergence of DevOps, and been part of that conversation as well. I've managed large code bases, large infrastructures, and normal-sized humans. When I say large infrastructures, I mean thousands or tens of thousands of virtual nodes, hundreds or thousands of physical servers, large code bases, 2.5 million lines of code, and beyond. So pretty big. The human's normal size. I'm here today because I want to help fast forward your success in deploying scalable, robust, resilient architecture. I was sitting where you're sitting a year ago. My goal here is to fast forward you as much as I can in the time allotted. Maybe it'll be a year, probably not. But if I save you a couple weeks, then that's a win. My experience is uniquely my own. Everything that I've learned up to this point has been driven by my own context and experience. So your mileage may vary. It may just be that the purpose of my life is to serve as a warning to others. Quick disclaimer. These opinions are mine alone. I'm here in an unofficial capacity, not representing any company. Any opinions expressed do not reflect the opinions of my current, former, or future employers, any of my friends, or any reasonable person. Any resemblance to actual infrastructure as businesses, places where people living or dead is purely coincidental. So this was mentioned in the keynote this morning. We can't talk about code without context. So I had this slide before that talk came up, just so you guys know. But I want to talk a little bit about the world of technology in 2016. So a while ago, somebody said, the DevOps revolution is really just a branding of what most of us have been doing for a really long time. Working together, talking to each other, releasing quickly, and testing to make sure things are working like we think they are. And I was the one who said that. This was a conversation at Velocity a few years ago. In 2016, DevOps says that we have a bunch of course we shoulds. These are different than they were in 2000, different than they were in 2005, different than they were in 2014. Of course, we should use configuration management software. If you've never used configuration management software, I have a vendor I can recommend called Chef. It's pretty great. Of course, we should version control our software. That's our applications and our infrastructure. We should write modular, pluggable code so features can be released independently. This is the foundation of the service-oriented architecture. And we should make our dependencies explicit. And of course, we should test and monitor our systems. I'm happy to report in 2016 that Agile, DevOps, Lean, Deming principles, whatever you want to call it, it's winning. Uprooting entrenched business practices is possible. I know some of you guys who've been in the enterprise have been fighting that uphill battle, but it is possible to win. When we win, it's because we're driving results. So less than a talk about principles or approaches, at the end of the day, the business cares about delivering value to the customer. So when we can more effectively drive results, we win. Existing processes have evolved to drive results in specific environments, right? The mess that you've inherited or the mess that you've come into didn't happen overnight by accident. It was a series of decisions, and part of what we're trying to do is realign the tools and incentives to allow for a better evolution in a better direction. So a year after ChefConf, I hold this truth to be self-evident. I believe that DevOps is not a tool set, but a mindset. It's a way of approaching problems collaboratively. We need to work together. And by we, I mean everyone. The community needs to work together, but operations need to work with developers. We need to work with products. We need to work with finance. We need to work with the business leaders. These are all people, we all need to be rowing in the same direction. If half of us are pushing on the door, and the other half are pulling, we're just negating each other. So let's be collaborative. We need to be effective. Last year's keynote, Jez Humble shared a startling statistic. 1 out of every 3 technology initiatives that is undertaken to drive a particular metric in one direction or the other succeeds. That means that 2 out of every 3 technology initiatives either add 0 or negative value to the equation. So that's a sobering statistic. We need to make sure that we're effective and driving solutions that move the business forward. We need to use fact-based decision making. So tests and data. This is why a lot of engineers are metrics obsessed, right? Because we can get very clear information that we can move in one direction or the other. And we need to be flexible. My infrastructure is not like your infrastructure. My business is not like your business. We need to work together to move things forward, but we need to be flexible in our approach because this is not a one-size-fits-all sort of thing. I believe that DevOps is a way of building things. It's about building repeatable process, right? The entire core concept of configuration management is about building repeatable processes. And continuous everything. Continuous deployment, continuous integration, continuous testing, continuous monitoring, continuous conversation with customers about what's going to drive value for the next iteration of the product, right? There's no done in 2016 in the world of technology. Anyone who thinks they're done is waiting to be disrupted by another player and run out of business. We're all moving forward, and it's continuous everything. Automate what you can, document the rest. As much as you can, turn this stuff into code. Part of the talk about Habitat is turning packages and things like that into code-based components. The Chef compliance stuff is about turning their compliance into code. So we want to automate as much as we can. Anything that requires human interaction should probably be documented. And we want to make sure that humans are doing work that humans can add value to. If you're manually running shell scripts every hour, probably suboptimal. Managing complexity is really important. How many people have been doing systems or dev work for less than 5 years? Okay, great. You guys are in for a heck of a ride. It's an interesting career path you've chosen. Building real stuff is hard. It's not impossible, but it's hard. And we need to understand from the outset that building real stuff is hard. Going from hello world to a large-scale performing application involves a lot of complexity. This is a pull quote from a talk on high scalability about Twitter when it was re-architected. The initial Twitter app was a Rails app that was down like 60% of the time. It couldn't survive under the weight of its own success. So they had to re-architect the entire thing. And one of the pull quotes that I found really interesting was, "The ghost of legacy decisions past always haunt the system." So decisions that you make, they're going to echo through your infrastructure, through your code base, and through your culture. So we need to manage complexity. I thought I was a genius when I figured out that managing complexity is actually my core competency and my main job. But it turns out I was like 40 years late to the party. So Brian Kernighan, who's the K in awk, said controlling complexity is the essence of computer programming. So I'm glad I got there. It just kind of bums me out that it took me 40 years to repeat somebody smarter than me. We need to implement high standards. This is not high standards. Who in this room wants to debug this or add features to it? Troubleshoot it at 3 o'clock in the morning? Yeah, burn it with fire, right?
Gas and matches.
Yeah, gasoline and matches, yes. The two. I don't think off and on again works in this particular use case. Now this is a funny picture, right? But there are similar code bases and infrastructures that are nightmarishly under-engineered, right? This is just a visual of that. So we need to implement high standards in how we build our platforms so that we can continue building our platforms, continue adding features, and troubleshoot things when they break so we can get things running again and get value back to the customer. We have to drive value for customers, internal and external, right? If you're building a continuous integration pipeline or continuous delivery, whatever, for internal teams, you need to drive value for those internal customers. If you're building features, you need to drive value for your external customers. Unhappy customers means no money, means everybody goes home. It is possible to drive incredible customer value. I didn't think life could get any better. I was wrong. Life got 50% better, no lie. Now, if we could all strive to be as magical and ambitious as the 3-wolf moon shirt, the state of infrastructure across the industry would be incredible. But we want to drive incredible customer value. Obviously, another silly example, but it illustrates the point. Whenever possible, we want to remove the complexity for the downstream user to even know about the complexity, right? There's a lot of this going on all across our industry, and that's a good thing. We want to make sure that nobody needs to know about the man behind the curtain. Most of us never do this. This is a well, and it's a bucket of water, right? Most of us have knobs or levers in our houses that do this job for us. Complexity removed is basically magic, right? And this is part of the beauty of infrastructure automation. Smartphones give us a world of communication in our pockets. Push-button car service, push-button food delivery, friend-making apps. And I'm about to show you a modern miracle of orchestration. Are you guys ready? Are you excited?
Yes.
Okay, awesome. Here we go. Ready?
Yeah.
Okay. So that's a hot pocket. The number of interdependent systems required for you to eat a hot pocket is literally insane. Agriculture, logistics, transport, processing, distribution, warehousing, retail, finance, electric, water, and sewer. You will literally never introspect that entire system. Your brain doesn't have the capacity to even know about all pieces of that system. And you'll rarely introspect any of those subsystems. Now, yes, that is a very silly example, and this is an insanely idiotic thing to say. But once again, it illustrates the point. Just like you don't think about transportation and logistics networks when you're eating a Hot Pocket, you want your business people to focus on the things that they want to do. So you don't want your sales team thinking about tech debt. You don't want your product team doing capacity planning. You don't want your devs worried about a flaky CI or CD pipeline. You want all these talented people doing the most important thing aligned with their talents, right? Wisdom from Louis C.K. Most people don't give a blank what happens as long as they get to do their favorite thing. So how do we get everybody in our organization to be able to focus on doing their favorite thing? Well, first we have to work together to establish success criteria. What does success look like? Now, in the case of continuous integration, infrastructure, resiliency, uptime, if you don't know what your developers are building, how can you support it? If you don't know what your business's plans are for marketing, right? You think marketing has nothing to do with engineering. Well, if they're spending $1 billion on television ads and expecting a 60% spike in traffic, then yeah, maybe it does. So work together and hold all groups accountable to high standards, right? We need to make sure that we're all working together, working to the best of our ability. Understand that failure is a when, not an if, and build around that assumption. Break down the project and deliver the most valuable pieces first. Again, this is about driving value for the business. So find the most valuable piece you can build, the MVP, and get that out the door. Clear prioritization and continuous improvement are critical. And working together as partners. Partnership is key. You take some of the partners out, the whole thing doesn't work. So now getting into some of the technical nitty-gritty, building the thing, or code infrastructure like this, maybe? I was in a largely greenfield organization. This was by design. We were spun off from a corporate enterprise with the intention of building an independent infrastructure so that we could move as rapidly as possible. I highly recommend this if you're building any kind of sort of skunkworks project. We were native AWS and went for a microservices architecture. Again, not having a lot of legacy really helped us achieve velocity very quickly. We went all in on 3 technologies: AWS, Chef, and Ubuntu. Everything else was up for debate. And that's only possible in a high trust organization. And again, you see where culture comes back, right? I'm talking about how we decide what technology to use, but if you don't have a high trust organization, you can't have those conversations because those conversations are taken over by other factors, right? So high trust means shared responsibility. We need to be working together, moving in the same direction. A house divided against itself cannot stand. Ultimately, we settled on Rails and Scala as our application code bases. Reducing the number of languages allowed for better knowledge sharing, better code reviews, and establishing well-defined best practices. The way we defined a service was a role plus a recipe plus an ASG. Now, obviously that also includes the application code itself, whether it was a collection of Ruby packages or Scala jars. Each service got a role which invoked a role recipe. The roles are usually 10 lines of JSON, so very compact, very short. And role recipes help with versioning. This concept confused me tremendously 18 months ago. So does anybody here have a question about roles versus role recipes? Anything I can help you with right now? Okay, I'm talking to a room full of people smarter than me. Awesome. So each auto-scaling group pointed to a launch configuration that had a role attached. So a host would come up, and it would know what it was, and Chef controlled every aspect of the system once the system was bootstrapped and had Chef role. The base role contained global packages like htop and locate, things we wanted on all the systems, as well as global recipes. So collectd, logstash, iCinga, things we wanted on all the pieces. There were unknown unknowns. We knew from day one that we would get some parts of the infrastructure wrong, right? And everyone in this room is going to get pieces of the infrastructure wrong. That's okay. Business needs would change, and in our case, they did. New tools and resources would become available that would change the equations for what was the best decision at a given point in time. We knew we didn't have all the information about the end state of the system, as we had not gathered the data. We could not gather the data without first building the system. We wanted to build the best system we could, but we had to start from incomplete information and ambiguous goals. So this is a quote from Richard Stallman about the development of Emacs. I'm a Vim user, but this quote has some value. Emacs could not have been reached by a process of careful design because such processes arrive only at goals which are visible from the outset and whose desirability is established on the bottom line at the outset. Neither I nor anyone else visualized an extensible editor until I had made one, nor appreciated its value until he had experienced it. Emacs exists because I felt free to make individually useful small improvements on a path whose end was not in sight. Right? So he's describing software, but you're definitely describing exactly the workflow of infrastructure as code. Because as the business needs change, the services are going to change, and as the services change, the infrastructure changes, et cetera, et cetera. So you're going to work with ambiguity. And this highlights one of the strange paradoxes of working with software. You don't always know what you're building when you start building it. Building it wrong means having to rebuild it later. Service-oriented architecture can help here because it makes it easier to swap out new pieces and add new pieces. If everything's talking over APIs on the network, it makes it a little bit easier. But for every wrong thing you build, every right thing you build wrong, and every right thing you don't build becomes a much beloved soul devourer known as our friend technical debt. Now, so we were talking about roles and recipes. How did we get to technical debt? How did that happen? Roles and recipes are tied to services. Services are tied to businesses' ambiguous, rapidly changing needs. That's just the world we live in. Ambiguity leads to guessing. Guessing leads to suboptimal solutions. Suboptimal solutions lead to technical debt. And hello again. This is how we get here. We want to manage technical debt. You can never eliminate it. The ghosts of legacy decisions past always haunt the system. So still wrong, but better. I can't speak for everybody in this room, but I can speak for myself when I say that I will literally never build a perfect system. Systems remain in motion. Today's perfect system is tomorrow's dumpster fire. I'll never build a perfect system, but I will make the system better than it was yesterday or last year. So this brings us to continuous improvement. Part 1 of 3, embrace the suck. Navy SEAL Mark Devine says, discipline begins with training the mind to reject discomfort and embrace the suck. Now, some of you may think, well, Navy SEALs, they're kind of like a whole different breed. I can't really hang with that. So we'll go with another thought leader. Jake the dog says, dude, sucking at something is just the first step towards being sort of good at something. So I don't know about you guys, but the Venn diagram where Jake the dog and the Navy SEALs overlap, like, that's a sweet spot. I want to go there. So continuous improvement means experimentation. We thought we chose the wrong tool for platform as a service. And we ultimately moved to Terraform. This meant learning Terraform. This meant building tooling around Terraform. We had to reject discomfort and embrace the suck. And ultimately, it was a much better solution for us. We thought we chose the wrong tools for metrics and monitoring. We investigated Prometheus and InfluxDB. This meant learning Prometheus and InfluxDB. We had to reject discomfort and embrace the suck. And in the end, we stayed with iCinga, Nagios, NRPE, and Graphite. We threw work in the garbage because it did not drive the result we wanted. So just by show of hands, how many people in this room could work on a project for a month and then have their boss say, it's okay to throw it out? Okay, so we've got some people in here. We got a maybe, like a maybe sorta. Right now, remember what I quoted earlier. 1 out of 3 drives the metric that we want, which means 2 out of 3 provides no value or negative value, right? So if you're not able to experiment, you've got a problem. See, we knew we didn't have information about the end state of the system as we had not gathered the data. We could not gather the data without first building the system. Some probably smart person said this, standing at this podium just a few minutes ago. So part of this is about knowing the unknown. How do we introspect into our systems? We want to know the health of our systems. This is going to be a critical part of building an infrastructure or supporting new feature development. We want to know the health of our services as well as our servers. iCinga was chosen as our monitoring and alerting tool. This was because we had experience with iCinga, Nagios, and NRPE. We could administer it ourselves at low cost, and custom checks were easy to write. All our monitoring configuration was chef-driven. Sensu had nice features, and evaluating it was put on the backlog. Newer isn't always better, right? But sometimes it is. So get the data. And even if you get the data, you might still be an edge case. Robin Blake apparently thinks Joel Schumacher's second bat offering is a great one. I got this screenshot while using incognito mode on my browser because I did not want Amazon to think I was trying to buy Batman and Robin on DVD. So speaking of reboots, our internal iCinga cookbook was the first one I refactored. Originally, we had a monolithic attribute file that contained all kinds of information about all kinds of checks. We broke this up into logical units. So here's something to write down if you didn't already know it. All the files in the attribute folder are compiled at runtime. So there's no need for everything to be in one place. It all gets compiled, so use your best judgment for logical separation. Because it doesn't matter, the system compiles the same. I didn't know that a year ago. I learned it in the meanwhile, and so I'm sharing that with you. We had a monolithic NRPE recipe that called each check specifically, which was fine when we first started building our checks. It was less optimal when we got to dozens and then hundreds of checks, and we did a similar thing of breaking these things out. Ultimately, it turned into a run list. Now, the interesting thing here was our services were calling the NRPE recipe, and when we changed from this monolith to a sort of more microservice-oriented approach, we actually wound up breaking a bunch of stuff in that it was calling the sort of main monolith. And we had to refactor a bunch of changes in the application recipes, right? So again, a lot of people talk about monolith like it's some sort of derogatory term and it's a thing that needs to be exterminated at all costs. But really, we got caught in the spider's web, right? Microservice thinking bit us, right? So there's not one right way or one wrong way. There's different approaches for different needs. And again, your mileage may vary. So keep that in mind as you approach your specific infrastructure problems. We chose Graphite, Grafana, and Carbon for our metrics. Chef powered these configurations. We used the Graphite handler to get the state of Chef, which was very useful. We knew that if we had a happy Chef, we had a happy system because our problems would self-correct. We used the elk stack for logs. And now that we were gathering metrics, alerting on failure modes, and aggregating logs, we had a pretty good baseline for the behavior of our system. So we needed to write some tests. We started with simple ping checks against local endpoints, added API calls with parameters and expected return values, and our functional tests actually would tell us when the API behavior changed. When we no longer got that expected string, we knew that something had changed and that a test wasn't updated. So we knew before it got out that things were broken. Which leads us to part 3, baking quality in from the start. At ChefConf last year, I learned about RuboCop. It was mentioned in passing in a talk, and then I discussed it in the hallway with a random person. Little did I know it would occupy my mind for the next several weeks and become a critical part of my development pipeline. If you take nothing else away from my talk, use RuboCop. I didn't create this, I found it, but I agree with its message, 100%. Making our dependencies explicit and making our exceptions explicit is really, really useful. So, it's a little bit of a headache at first, but in the end it works. This is a pre-commit hook that basically says any added, copied, or modified Ruby files, check them with RuboCop. And if it fails, then output the RuboCop output and exit 1. So we basically pushed the introspection and testing right to the developer laptop, right? You could not push bad code into the repository if you were using this pre-commit hook. So once you do the initial legwork of getting your repository linted, this kind of methodology keeps it pristine, right? Community guidelines reduce the scope of controversy and allow for faster onboarding. If people come in knowing best practices and you're using those best practices, it makes it a lot easier. It also makes debugging community cookbooks a little bit more intuitive if you've tripped over some of the things that are happening out in the world. I added other linters, the pre-commit hook, knife cookbook test, food critic, and shell check were very useful. The more tests we added, the more bugs we caught, and the faster we could deploy. And remember, the key thing is deployment velocity. We did chef tests with Test Kitchen and integration tests with custom scripts. So testing is the difference between this and this, right? The fastest consumer automobile right now can drive 270 miles an hour, but I don't think it can do that here. right? And again, it's about removing obstacles so that people can get their ideas out. And this was, said in the keynote again, get the ideas into production as quickly as possible. The faster we could deploy, the faster we could add features, drive value, and correct mistakes. We want to move quickly, but not recklessly. Driving value for the customers is, again, the #1 job. And complexity removed is basically magic. Building stuff is hard, but it's amazing. And in conclusion, building stuff is hard, but rewarding. You wouldn't be in this room if you didn't already think that. Remove complexity where you can. Manage it where you can. Version control all the things, and document the things you can't automate. Use data to make decisions. Do experiments to get data. You're going to get stuff wrong. That's okay. Everything you build is temporary. Get better data and improve. It's the classic OODA loop. Innovation requires collaboration. You can't operate in an echo chamber. You can't do it alone. So collaborate with the people in your organization, collaborate with the people in the community, and you will create innovation much more quickly. Drive value to the customer. That's the whole point. Embrace the suck. You're learning new things. If you're new to Chef, you're learning new things, and there are going to be times where you're going to smash the keyboard and curse a lot. I've redacted that from this talk. But the key is you have to embrace the suck, move through it, make progress. Right now I'm learning Scala, and I don't know why it is so terrible. But the reality is it's not terrible, I just don't know it well enough to understand it. Pave the road to faster deployment. And bake quality in as soon as you can. Test, validate, and link all the things. And if you need a mantra, here it is. Never perfect, always better. You're never going to be perfect, your infrastructure is never going to be perfect, your business is never going to be perfect. But everyone in this room has the ability to make things better than they were last week, last year. And for leaders. I don't care if you're a senior engineer, you're a CTO, a CEO, an entrepreneur. This is for you. Culture can double or halve your team's productivity. It's really important. High trust is directly tied to better customer outcomes. So if you care about revenue, you should care about internal culture. And your relationship with failure will determine your team's success. Only a few hands went up when I asked if you could throw away a month's worth of work. Everyone in this room should be able to raise their hand. That will drive better business outcomes. Promise you. Collaboration and communication are core competencies for all roles. Everybody needs to be able to work together. You can't work together if you can't communicate. Make decisions with data. If you're guessing, you're guessing. Don't guess. And remember, your team, your organization, your product, it'll never be perfect, but it can always be better. So in closing, I want you to remember these wise words from perhaps the greatest movie president besides Bill Pullman. Be excellent to each other. And party on, Austin. Please don't build Terminators. Thank you. Any questions? Anything I can help you with?
I'm curious about roles. I was talking to someone, they said they can't be versioned, but you brought up role recipes.
Ah, yes. Okay. Remember when I said I was confused about this 18 months ago and did anybody have questions? It's for exactly this reason, right? So roles are just JSON files. They're kind of dumb. They contain attributes that are applied prior to recipes being applied, right? So your role is sort of like your top level construct, right? Now, if you build a role that says, here's the name of my role, and it contains my base recipe and also the recipe for this given application, it'll apply that recipe. Does that make sense? Everybody on board with that? Okay. So when you version your cookbooks, you specify your versions in your environment JSON files, right? You can't specify it in your role cookbook. So what you can do is you can update your role recipe and then bump your version in the environment file, and then you can deploy to that environment, right? So if you make a change to an attribute in a roles JSON file, it just goes everywhere. You can't control whether it goes to staging, because staging is using version 2.3 and prod is using 2.1, whatever. So you want to keep your roles JSON files as minimal as possible, and you only want them to contain the information that is required prior to recipe bootstrap. Does that make sense?
Not completely, but.
Okay.
Was the meta RD files, that's where you've got.
So,
your recipe.
I very much want to solve this problem for you today. I don't have a whiteboard, so I can't do anything because I don't know how to operate without a whiteboard. But let's talk afterwards, and we'll go through some stuff. And if you have some cookbooks you want to look at, we can step through exactly those problems. And anybody else who wants to be involved in that, please join us. I want to help everybody in this room fast forward your success and your understanding as best as I can.
So you said you were committed to AWS. Why did you choose to go with Terraform versus just like straight cloud?
So, and again, the algebra of this may have changed in the past several months. We were using CloudFormation, and we migrated away from it. Terraform gave us a little bit more ability to manipulate variables and inject those variables into the configurations. So it was a little bit less about hard coding and more about sort of dynamic. We were able to define our environment stacks based on parameterized criteria, which CloudFormation is just much more difficult to do that. Now that may have changed. This is the trick, right? The right decision can become the wrong decision just because an external circumstances change. I really got a lot of value out of Terraform. I would recommend that you check it out if you're not familiar with it. Any other questions? Question?
Did you look at ChefConf as an alternative to iCinga to solve the scalability problem in the check?
So ChefConf, did you say? I'm not familiar with that. The question was, did we investigate ChefConf as an alternative to iCinga? We mainly looked at Prometheus, which was sort of the new kid on the block that everybody was raving about at the time. The configuration was sort of a little bit heavy, and we weren't really getting a lot of value out of it. So we decided that we were just going to sort of add resiliency to our iCinga infrastructure and kind of drive down some of the complexity of some of the checks. Nagios, everybody hates Nagios until they use something that isn't Nagios, right? NRPE was kind of a known quantity, so we just decided to stick with that. Any other questions? All right. Guys, thank you so much for your time.